All right, guys, so this is our last day of this unit, and we're going to talk about our fundamental theorem of algebra. This is something that pops up a lot, but is actually just ways to help us solve and find solutions to polynomials. So first off, the degree. What is the degree of a polynomial? The exponent is that highest exponent that we have. So that tells us if it's quadratic, cubic, quartic. That number tells us the possible number of solutions that we have. So if it is a quintic, it's going to have 5 solutions. Now, some of those solutions may be imaginary. And if they are imaginary, they come in pairs. And if they are irrational, which means the decimal goes on forever, keeps going, no repeats, then they also come in pairs. Because how do we get imaginary numbers? Negative where? Under a square root. And anytime we take a square root, what do we have to put with our answer? Plus or minus. So that positive and that negative makes 2 solutions, right? Okay, so that's why they come in different pairs that we have. So the degree, if it's a power of 5, you could have 5 what we call real solutions, or you could have 3 real and 2 imaginary, or 1 real and 4 imaginary, just depending on what we have. Now, the ways that we solve a polynomial, you can use these steps every time. You first graph it on your calculator to find an x-intercept, and notice I put to find a rational x-intercept. So rational means that it can be written as a fraction, so it's a integer, or it's something like 2/3 or 1/2, something like that. Then we use synthetic division at least once. You might have to use it twice to find other zeros. And once you use that synthetic division, you're going to solve for x by using one of these methods. Square roots, factoring, complete the square, or quadratic formula. Okay? Sometimes we don't have an option of what we need to use. Like we can only use factoring when we can factor it. We can only use square roots when it's just an x squared in the problem. Completing the square, most of the time we want to use it if it's a 1x squared. Quadratic formula, you can only use on quadratics. Okay. All right, so we're going to go through 6 examples, and there might be multiple ways that I'm going to tell you that you can solve them. So just be prepared for that. All right, let's look at problem number 1. Write these down one at a time because you want to make sure you got plenty of workspace to do it. Now, this problem is a what? What's the power? 2, so it's called a power of 2, quadratic. So we're going to have 2 solutions here. Now, we know how to solve quadratics back in our last unit and this unit. We could complete the square, we could quadratic formula, we couldn't solve for square roots, but it could maybe factor. But we're not going to use those methods. We're going to use our new method. So first step is to graph it on your calculator. So everybody get those calculators? Let's go to y equals 2x squared plus 5x plus 3. Don't worry about the equals 0 part. The equals 0 part is just telling us that's what we want to solve for x. Do you have your graphing calculator? Okay. Now, once it is graphed, we're looking for the zeros, the x-intercepts, the roots, whatever you want to call them. Do you see where it looks like it crosses the x-axis at? Looks like it crosses right at -1, right? Right on that line where it crosses. So you can hit trace and then type in -1, just like we did with finding our key features. Is that a x-intercept? How do we know? Y equals 0. Remember, you can also go to your table and look where y is 0, and that will tell us that we have a y-intercept. So we have it right there at -1. So we are going to use that number as one of our answers, but then we also use that number in our half box for our synthetic division. So what's going to go beside that half box? 2, 5, and 3. And then what do we do with our first number? Bring it down. And then multiply by what's in the half box. So negative 1 times 2 is, and then 5 minus 2 is, and then negative 1 times 3 is, and 3 plus negative 3 is 0. Now, if it is a true x-intercept, that also means it's a true factor. So if it's a factor, what's always true? The remainder is 0. Very good. So since we have a remainder of 0, we've done it right. So everything that you do today with synthetic division should have that 0 remainder because we're looking for x-intercepts. We're looking for factors. And so that will be in place for this. Now, write this as an equation. What would it be as an equation? 2x plus 3. That's right. Remember, it's 1 less when we divide it, right? So if it's x squared here, 1 less is just x. And now what we do, a little bit different from yesterday, is we set that equal to 0 and we solve that equation. That will give us our another x-intercept. So when I solve this, I would subtract 3 and so x equals, and that's our other solution. You can go back in your calculator. Since it's already pulled up, you can go to your graph, trace, type in that solution, negative 3/2. Does that give us a y value of 0? Yes, it does. So these are ways to find your x-intercepts using your calculator and synthetic division to help us find what those are. And then you can also use the same way to help you with factoring as well. So just a little extension here. This is one of your factors, 2x plus 3, and your other factor would be what? X plus 1, because it's the opposite. So if you ever had to factor this polynomial, if you find one of the x-intercepts, remember you put the opposite in the parenthesis, you can do synthetic division, and it will give you your second factor. Now, you could have also done quadratic formula on this. You would have got the same answers, complete the square, same answers as well. All right, let's look at problem number 2. Write that one down. In number 1, we had a power of 2, so we had how many answers? 2 answers, right? We had negative 1 and negative 3/2. In problem 2, what's our degree? What's our highest power? 3. So how many answers should we have? 3. All right, let's start off the same way that we did our last problem. How do we start this one? Graph it. So let's go to our calculator and graph. 3x to the third. What do you notice about this graph? Yeah, it's a little curvy. What else? It only intercepts the x-axis once. But how many solutions should we have? 3. So what does that mean about the other 2? They're imaginary. That's right. We can't see imaginary things where they cross. So we have one real solution. The other ones are imaginary. Where's the solution at? Negative 1. Just check it really quick. Trace negative 1 enter. Y value 0 must be a solution. So we're going to use negative 1 as one of our solutions. And then we're also going to put that in our synthetic division. All right, what's going beside our box? 3. What do we do with our first number? Okay, then we multiply and multiply and multiply and good. Now, once we have done all that, we need to write an equation. What's the equation? Very good. Now, we have a couple of different options. We need to solve this for x, so it's not a linear problem like the one before. It's a quadratic. So if it's quadratic, we've got three methods that we can use. If it's a quadratic trinomial, we can try to factor it. So maybe let's start there. Maybe it's factorable. How do we factor this? Okay, multiply the first by the last using our grouping method. So we get 3x squared equals blank times blank. And then negative 2x equals blank plus blank. Yeah, it would have to be a negative 3 and a positive 1, but will that multiply to make a positive 3? If it multiplies to be a positive, the signs have to be the same, right? So either they're both positive, which would make 4, or they're both negative, which would make negative 4. So does this factor? No, unfortunately not. All right, so now I have to choose another method. We could either do quadratic formula or complete the square. I had a feeling y'all would say quadratic formula. So let's pick out our A, B, and C. So A is B and C. Good. And then let's sing our song. X equals opposite of B plus or minus square root. B squared minus 4AC all over 2A. Y'all have such beautiful singing voices. Just keep it up. That's right. We can sing our quadratic formula song, put everything in the right spot, and then we want to simplify. What do we simplify first? Denominator. So 2 times 3 is 6. And then we simplify what is in the square root underneath, not the square root itself. Remember, don't type in the square root, just what is underneath. And so underneath that square root, we get negative 8. It's a negative, which tells us what? We're going to have we're going to have imaginary solutions, right? And that what Izzy said earlier, it doesn't cross, or somebody said earlier, it doesn't cross, so the other two must be imaginary. It only crosses once. So we've got to break it down and simplify it. What multiplies to be 8? So x equals 2 over 6 plus or minus, simplify that square root negative 8 to be, very good, 2I square root 2. Square root of 4 is 2. Got to take the I out because it's negative. And then our 2 stays underneath. Then we can simplify some more. We can simplify our fractions. 2 over 6 reduces to 1/3. And in both cases, they would both simplify to 1/3. So our next answer would be x equals 1/3 plus or minus I square root 2 over 3. How many answers do we have when we do quadratic formula? We get 2, right? Because of the plus and minus. So we have 2 imaginary answers here. And then our third solution was up here with x equaling -1. So will you see quadratic formula a lot on these problems? A lot of people usually ask me that because they take a little bit longer, right? You won't see it quite as much. There may be something that you could factor. It may end up being like a linear problem where you could go through that as well. I do want to show you one other way to solve this besides plugging it in the calculator. We know what to do when there's 4 terms, right? When there's 4 terms, you could do what with your problem? You could group them and look for the GCF. If they end up having the same parentheses, then it could be factored. Let's see if that works on this problem. What's our GCF here? X squared. Okay, what's our GCF here? -1. If we factor those out, would we get the same thing in our parentheses? Well, let's factor out x squared. What are we left with? 3x plus 1. Over here, what are we left with? X minus 1. Is this factorable like this? No, it's not, because we need what? We need the same thing in the parentheses. The parentheses need to be the same. Are they the same? No. So this one is not factorable that way. But sometimes when you have 4 terms, you can factor it in that way. All right, let's look at problem 3. Y'all write down problem 3. Now, what's the power on this one? It was 4 terms. What's the power, though? 3, yeah. So how many solutions do we have? 3. So a couple of ways that you can do it. And I already see some people go ahead and typing it in the calculator. You could go ahead and type it in y equals. Let's see what it looks like. X to the third minus 3x squared. So what do you notice about your graph? It just hits the x-axis once, so it has an x-intercept at 3. Remember, you can go to your table to look at that. When x equals 3, the y value is 0. That's another way of looking at it. So the other 2 answers that we have are imaginary. Now, you could do your synthetic division. You would put what number in the box? 3, and then put your coefficients beside of it. Or, let's try the last method that we had. The last one didn't factor, right? We had 4 terms and we could group it. Let's do it on this one. Let's group these and group these. Let's see if we can factor this into something. There's 4 terms. Try grouping. What do the first 2 have in common? X squared. What do the last 2 have in common? Just 1. So let's factor out that x squared. What are we left with? X minus 3. Good. Power over power, you subtract. Factor out a 1 here, we get. Are my 2 parentheses the same? Yes, so this can factor to x squared plus 1 and x minus 3. So if you know how to factor by grouping and you're good at that, go ahead and do it. If you like consistency with doing the same thing on every single problem, find that x-intercept, do synthetic division. When you do your synthetic division, guess what you're going to get out? X squared plus 1. Okay? But now that it's factored, we take each parenthesis and set it equal to 0, just like we did in our last unit, and then we solve them. Now, the one on the right is very easy to solve, right? X equals what? 3, which is what we got out on our calculator, right? We saw it cross there at 3. Now we need to solve this one, just like we did at the beginning of this unit. How do we solve this? Subtract 1 and then square root. Anytime we take a square root, we have to put plus or minus. And it's I. Just I by itself. Square root of -1 is I, that imaginary number. There we go. So if you like factoring and it does factor, use that. If you don't like factoring, you don't have to. You can just go through and do our synthetic division. All right, write down problem 4. This one is what type of problem? It's a quartic. So we have how many solutions? 4. I want us to do this one with our synthetic division way, although I know that you guys could factor it and go from there, but I want to try this one with synthetic division. So let's type it in our calculator and find an x-intercept. 4. Yeah, this one makes a nice W shape, right? Okay, so you can, it kind of does, inverted McDonald's. All right, remember you can go to your table to help find your zeros, or you can look at the graph. But where are zeros at? -2 and +2, right? It gives us 2 of them, which is great. If it gives us 2, we're going to use both of them. So x equals +2 and x equals -2. Now let's do our synthetic division on this problem. So I'm going to put 2 in my box. Okay? What's going beside my box? Good. There's a couple of zeros in there, right? Now, remember what I said yesterday? I don't know if I said it to you guys, though, so let me make sure I say it. If it's a power of 4, we have 1 extra term. So if it's a power of 4, how many terms are we going to have? 5, because you have the 4th power, the 3rd power, the 2nd power, the 1st power, and then the constant. I just used the first one. You could use either one. Yeah. Okay, now let's do our synthetic division. So bring down, multiply, and add. Did I do it right? Oh. Sometimes I have issues multiplying too. Yes. And guess what? We can use, since we have another answer, we can do it right here at this spot. You don't have to write this as an equation. If you have another x-intercept, you put another answer there. But remember, we don't need this remainder part anymore because we don't do synthetic division with the remainder. So you're going to have one less column that you have to deal with. So if you got 2 zeros, do it again. So what do we do with our first number? Bring it down. Then multiply and add, multiply and add. Don't forget, 0 times anything is still 0. And you got to make sure that your remainder is 0. So on the first synthetic division, if you forgot one of those zeros up there, you're not going to get a remainder of 0. And that's usually the common mistake there. If you don't get a remainder of 0, maybe you forgot a 0 in your initial row. All right, but now that we have this answer, now we write what it is. Now you might want to go in reverse because this is the, and then we have, good. So if I want to write this part as an equation, it is, good. And go ahead and put equals 0 because we are going to solve that equation for x. All right, so now what do we do to solve for x? Add the 3 and then square root. This up. So x would equal, there we go. Don't forget that plus or minus. So how many answers do we have right here? 2 answers. We got a positive square root 3, a negative square root 3, and then we should have 4 altogether. So the other 2 answers were -2 and +2. Now, since these are real answers, we can check them on our calculator. So if you want to go back to graph, you can click trace and type in square root of 3 as an x value. If you type in square root of 3, what's your y value? 0, so it's a solution and it works. And then you can also type in your negative square root 3 as your other solution. And so you have those answers there. Now, like I said, you could have done what to this? You could have factored it. How do we factor a quartic? What multiplies to be the last, what adds to be the middle. And Gabby, you're right. You want to have x squared and x squared in your parentheses. So what multiplies to be 12 and adds to be negative 7? Good. Negative 4, negative 3. Now, that equation looks just like that one, doesn't it? X squared minus 3. So the only thing we would have to do here is take our x squared minus 4 and set it equal to 0. Oops. And what would you do to solve that? What's the square root of 4? 2. But don't forget to put what with it? Plus or minus. Plus or minus 2. So you could actually say here for this answer, x equals plus or minus 2, and then x equals plus or minus square root 3, like we did down there. So you can decide if you want to factor it or if you want to find a value and use our synthetic division. Okay? And then that could also factor some more. I didn't say that because that's a what? Perfect square or difference of squares, so it will factor to x plus 2 and x minus 2, which would still give us the positive 2, negative 2. So I wanted to show you lots of different ways because it just depends on your preference. I don't want you to have to pick an exact way to do it. You should kind of use a variety of ways to do it because different problems have different methods to solve. Erase some of this. I got room to write. All right, how do y'all want to go through and solve this one? Okay, so y'all want synthetic? Y'all want a group? Why don't we branch out? Do synthetic, do group. Let's go. See which one works. 1 and... Yes, that's it. Very good. Okay, I got several pencils there behind my ear. Yeah, well, let's see with the other one. The other one's a little bit special because how many terms do we have on that one? 5. So could we do grouping on 5 terms? No. So write this one down, type it in your calculator, and let's find those x-intercepts. Because it's x to the 4th, so if it's to a 4th power, we got the 4th, 3rd, 2nd, 1st, and then the constant. It could have 6 terms if you had a x to the 5th, if you had a quintic. Okay, now make sure that you type it in correctly because it will not look so hot if you don't. Yeah. Uh, 16 minus 4x to the 3rd plus 8x squared Now, did you expect that graph? No. Normally, when we see a quartic function like the last one we saw, it kind of looks like a W. But remember how at the beginning of this unit, we talked about that quartics could look like quadratics, and this looks more like a quadratic. Do we see where it crosses the x-axis at? Yeah, it crosses at 2. Yeah, you could double check it. 2, y value 0. So we're just going to use that value, okay? So x equals 2, and we're going to put 2 in our box. And then we're going to keep going with our synthetic division. Remember, the remainder must be 0. So double check your work. Make sure you get 0 there at the end. No. All right, now, if we write this as an equation, it's going to be an x to the 3rd power, right? Okay, so we've got a couple of different ideas that we could do with x to the 3rd. If we wanted to write this out as an equation, I'm going to write it out over here to the side. It would be x to the 3rd minus 2x squared plus 4x minus 8. Now, with this, because it's got 4 terms, you could use your grouping method. But let's say you don't remember that method or you forget that method. How are we going to solve a cubic? Well, we can only do that if it's a cubic binomial, right? If it's a difference of cubes or sum of cubes. Well, that was with the quartics. So that's, yeah, cubics only work if they're binomials. You could, but that's not really going to help us solve. But guess what we could do? We could just do it again. Type that in y equals. Figure out where that crosses. So you can use the same method multiple times. And let's see what happens when we put this one in y equals. And some of you may have noticed it when y'all looked at that original graph. Now it's got that little curve in it, right? But where does it cross the x-axis at? 2. What do you know about 2 then? It's the same answer twice. What do we say if we get the same answer twice? Multiplicity. This 2 has a multiplicity of 2. And if you looked at the original graph, it looked like this, and it hit at that point 2, 0. It bounced back off. And what do we say if something bounces off the x-axis? It has a multiplicity of 2. So guess what? We can do this again with our 2. Cutting off that last part just like we did with that quartic that we did a while ago. So if it bounces off, don't forget you can use it again. And as long as the remainder is 0, it works. Very good. So let's bring down, multiply and add, multiply and add, multiply and add. Now let's rewrite this as an equation. It would be, good, x squared plus 4 equals 0. And then solve that equation. So what would you do to solve? Subtract the 4 and then square root it. X would equal plus or minus 2i. Does it make sense that this answer is imaginary or these two answers are imaginary? Yeah, because the original graph only touched the x-axis at 2. So do we still have 4 answers? Since it is a quartic problem, we should have 4 answers. Yes, we got positive 2i, negative 2i, and x equals 2 twice because it had that multiplicity. All right, so we are going to work in some groups now to work on our homework, but you do not need your Chromebooks out because I printed the problems for you on a little piece of paper, so that way you can work in groups to do these. Now, the reason I want you to work in groups is so that way you can kind of talk through them, like if somebody has a question, they forget how to do it, or you can remind somebody, hey, that can be factored, or hey, why don't we type it in the calculator? I got a positive 1. I got a negative 1. So you can kind of talk about it and see what you got. Don't write on these papers because I am going to use them for the other classes. So I'm going to give y'all 2 so that way y'all got 5 people in your group.